SwayamPrabha. Digital India. Educated India.
So, if you have understood what are the aims of the landform design, let us go forward. I am just putting the slides once again to reiterate, recap. For efficient drainage, for facilitating building and roads and other functions, for creating pleasing effects, to fitting design elements there, and to perform landform reclamation activity. These are the primary aims of the landform. Now, let us fall back on the analysis. We have done a set of analysis, and you remember that I said in the whole process of landscape design, you should do the analysis before, not when you are working on these different aspects and trying to solve the issues. Because if you do the analysis before, then what happens is your preliminary plan is already prepared and rest of the things are detailing it out. So, what are the relevant analysis that you have done earlier? You remember the list of analysis that I have given earlier, out of which are relevant for this particular landform work. Here in this you will find, so essentially vicinity analysis you require. Why vicinity analysis is required? For landform, what will be the profile of your entire land will also depend on what is the profile of the surrounding. It is something like this. If suppose you have a flat land and you have the hilly areas all around, of course, to create a contrast you can keep this as flat, but it is always desirable that the profile of your landscape land also goes in harmony with the surrounding landscapes. You remember I said that earlier. So, vicinity analysis you are now going to take care of. Land use analysis, because the land use is going to be here, since you are mixing land use and the landform together. So, the land use analysis you have to know. If it is such kind of activity where the land use is such that it is not really very much manipulable or changeable, then this land use analysis is going to guide you on that. Physical features, utilities and service lines, because here I will discuss this when I will talk about the criteria. I will see there are certain physical features which are going to be constants to us. There are certain physical features which are going to be maybe useful to us. This you have to understand. Contour analysis, because I need to see how is the existing contour. Slope analysis, I need to know how is the slope. Now, if I say with respect to the aims, you will find the contour analysis will give you the relative idea of the levels. The slope analysis will give you the idea of the slopes and steepness of this. Now, where you are going to put what kind of functions, that means the facilitating the functioning positions of all these, locations of all these will be now very much guided by the contour and the slope analysis. And then again, fitting the design elements to the site is also going to be supported by these two. Drainage analysis, because drainage is one of the prime objective of my landform. So, drainage analysis I must know. I should not do any kind of landform activity which is going to stop my drainage. I will just give one simple example of this. I had a land like this where the entire region's water was passing and it was flowing like this because of the slope, and I have my property which is limited to this. I am drawing a section in section. My property is limited to this, and my owner or me as a designer, I wanted, no, I do not want this kind of slope land, I want to make it flat here and then sloped here. Possible, anything is possible, you can do this. The moment you do it, your landform activity you have done, and you can always claim that within my site whatever I can do. But the thing is, the moment you have done this, what you have done is this particular flow of water now got impeded. Originally which was flowing like this, now it got impeded over here, interjected. This is not right. So, what happens is your drainage analysis will guide you. When you are trying to do some bit of landform changes, then immediately the drainage analysis has to be followed. Okay, let us see, refer the drainage analysis, and if you find it is not creating much of a drainage problem, then you go ahead with it. Or in case you find that there are certain areas where you have the flatness and you want to take the water, rather you want to enhance the drainage because the drainage is being blocked or rerouted, then the landform. Okay, these details I will discuss one after another, but this is how the entire set of analysis will be required. Geological based analysis is for the soil and its subsoils, soil analysis for the topsoil because that is what you are going to handle, and the visual analysis, how it looks like, the profiles. So all this set of analysis here, I don't remember, about 14-15 analysis I listed earlier and explained. Out of these, so many such analyses already would be helping your ADQ in your landform plan design. Let's go to steps. If you follow the steps, I will try to explain the steps as briefly and as discreetly possible so that you get the idea of it. There will be some broad, maybe there are some details which I will talk about. The broad steps. First, you are supposed to do the landscape design within which the landform design. So what happens is, now here whether landscape design first or the landform design first, many of my students ask this question. My point is, everything is almost integral, they go side by side, because the landform design is a part of the landscape design that you are doing, and within this, if it is, then when you are creating the landscape, automatically the landform also you are creating. So you are creating a landform, checking with the overall landscape concept of yours, and then trying to adjust the landform, and then trying to work out and change your original concept of the landscape. So don't try ever to contest against each other. No, it is always integral and they are simultaneous. Okay, so what you do now? First, you study the existing landform profile, whether it is undulated, whether it is flat, whether it is one slope, or whether it is peaked like this, whatever you study. And then you study the soil type. Within that particular site, what are the different soil types that you do have? Means I am just listing few here, there are many more soil types. So you can, in terms of types, there are, like say clay soil, loamy soil, sandy soil, silty soil, black cotton soil, rocky, micaceous, alluvium. See, different kind of soils. For this, I would advise you that you please read or go through very fundamental or scientifically written books on soil, I would say soil engineering. Now, when you know about the soil, basically what happens is, the soil is the component that you are going to handle, and if you understand the soil well, it is not necessary that you are going to use only one category of soil in your landscape or landform. If you understand the soil well, then in such case what happens is, you know how to handle it, how to manipulate it. Okay, so basically it is nothing but, as if like cooking, you are trying to cook a dish and you have multiple such components, and each of these component ingredients that you are going to put in the recipe, you know what it is going to make what change is similar. And I can also tell you that if suppose you have if you are lucky to have a little larger landscape site, then the soil also need not be just one type. There may be, by virtue of the natural creation of the earth's crust, there may be a little bit of variations of soils within your type soil landscape domain itself. So try to understand different kind of soils, okay, and then you study the composition of the soil. This let me explain a little more. The composition of the soil, if I try to show with respect to the pie diagrams, is something like this. If this pie diagram represents the soil, it's something like you dig out a bundle of or clod of soil and try to analyze it and try to see the composition of it. The very common composition that is understood is like the soil would be having almost 50-50 of the materials. One is the set of soil particles, then another is most common divisions of the composition is 5%, 45%, and then it is 25 and 25%. What is it? This 45% is actually the soil that you do see, and this is nothing but mineral components. Mineral components of various size, different granulated size, mix of different sizes. This 25% is filled with air, and this 25% is filled with water. And what is the 5%? It's organic components. Or let me write organic compounds, which is this organic compound mostly being contributed by the vegetations which are decayed, which were there, or even some organic components which came and got mixed up with this, because it is the whole process of the natural soil that you do see, it has grown over time and it has undergone a lot of changes. There had been erosions, water erosions, wind erosions over this. There had been vegetative growth over it. There had been decay of vegetative growth. There had been death of vegetative growth. There had been burying of vegetative growth. All these things happen. And in the whole process, what happens is, sometimes you might find that there is a soil area which is very, very one type, but doesn't have much of vegetation. But still, if you dig the soil, you will find that there is a good quantity of decayed vegetation. This you should attribute to a situation when from upstreams some vegetations had been flown away by water, brought here and then got stuck here and ultimately decayed and got embedded. This you have to understand. So this is a very typical composition of it. Now the question of 25-25 of this water and air, very interesting. Sometimes you dig a soil, you find it's very dry. Sometimes you dig a soil, you find it's moist. So the moistness and the dryness is nothing but the quantum of the water that is contained within. And if you find that the water has crept into this particular soil and you are digging and you get the soil so easily, then you should be very clear that there is more quantity of water. In this picture sheet itself, let me draw one more thing. Basically what happens is, let us consider a soil as a composition of, say, combination of lots of particles. So in general what happens is, and all these particles of whatever kind of crystalline or geometric form it is, for my convenience of explanations, let me draw it as sphere. In my drawing it is circular. So what happens is, there are such soil particles which are of different sizes. So basically when you dig a soil from this particular part, it is a combination of multiple sizes of these particles, big to small, to small powders, or such kind of structures. Now if I just enlarge one of the part a little more, say this particular part I am enlarging, it is basically one big particle, another big particle, and another big particle here. In between there is a large particle and a small particle, another small particle, and another big particle, another particle here. If you do see here, definitely you can identify that there are air spaces in between. So basically what happens in the reality, when the soil particles of different size and they are of irregular profiles, not necessary, it is only in sand that we do see that if you take say multiple such sand particles, and if you take a magnifying glass and see, they are almost of the same profile. Sizes are different, maybe same profile, but in soil it doesn't happen. In soil what happens is, multiple different sizes of profiles, different sizes of minerals, they are mixed and ultimately came to us as a soil. In such case what you will find is, since the profiles are different, so they cannot match on the edges very uniformly, and if they don't, then in between they have interspaces. These interspaces are the ones, interspaces or voids, let me call void, it will be easy for you to remember. So there will be voids. These voids are filled with either water or air. In fact, there is no scope for air and water to be at the same place almost together, because the water, if it has entered in some area, then air must have been escaping and it has replaced the air. So in such case what happens is, when you are seeing this, basically if you take now a cloud of soil and then you have a magnifying glass and try to see through, then you will find there are lots of voids in between where there are entrapped water, and that portion is moist, and there are other portions which may not have entrapped water, but they have their air. So this quantum of air and water is a matter of how much water crept in, how much the water went into the in between spaces, how much water could escape, make the air escape and fill it up. And at one point of time, when you find that the entire air has been escaped, so now the particles are held with only water, In some cases, when you find that the water has escaped, how the water will escape? Either by drainage, natural drainage by percolations, or by evaporations. And then if the water has escaped, air has crept in into the voids. So naturally, a standard composition of a soil, now you look at the same pie diagram here, but mind it, this 48% is the mineral component, that is basically the soil that we are getting. And now just look at it. If suppose I compress it, press it together, basically what I am doing, I am pushing the particles close to each other, and more I do it with some pressure, then naturally air and water will tend to escape. It is just like you take a piece of cloth which is moist and you try to rinse it. Once you try to rinse it, basically what happens is the clothes will have lot of fibers and the threads, and they will have interspaces which is filled with now water, that is why it is moist. And the cotton fibers are also filled with water, that is why it is moist. You rinse it, you allow the water to escape and also the air to escape, then you find it has been almost like very semi-dry. This is the same situation with the soil. When you handle these soils, in such cases, try to understand what is its composition. Okay. The next one, study the chemical properties of the soil. The chemical property of the soil will be governed essentially with chemical components that is within. It is potassium, calcium, nitrates, all these are ferrous, these are all different kind of minerals or materials, that metals that we do have in this, and these chemicals makes the difference in terms of the soil's quality. It is by this when we find that there are some of the chemicals which are more in quantity, we term this as a soil as acidic. Some which has more of salinity, we call this as saline. Some we call as alkaline. So if you now fall back into your knowledge of chemistry, that acidity, alkalinity and salinity and neutrality, this is the basic way by which we always try to identify what is the chemical property of a soil. This chemical property of the soil here, it does not make much of a difference in terms of its landform work, but understanding of this is important for one reason. This chemical property of the soil, which is going to be finally aiding or helping the vegetative growth or the structure of the vegetation, there these chemical properties will start playing a role. A soil which is very acidic, soil which is alkaline, if they are physically strong enough and equal, it does not make any difference in terms of chemical properties. So the chemical properties we should know, not essentially for landforms profile making or stability or to increase the bearing capacity. Basically we need to know the chemical composition just to see that this landform over which my vegetative growth will take place, and how the vegetations that we are thinking to place over this and is going to be helped by the soil which contains some chemicals. This is how it should look at it. Okay. Study the soil structure. See, soil structure, there are two things which you must not ever miss. Why I am highlighting all these things, quite often I have found many of the architects, many of the designers are not very clear about all these things. Landscapists also not very clear about all these things. It is not because of that they have the lack of knowledge, it is only because they didn't really realize that how much this can make sense in our planning. So I am just trying to give a little bit of brief idea about it. Two things, soil structure and soil texture. I will show you through diagrams also. Basically soil structure is how it is bonded. See, soil is nothing but again the group of particles held together with something. Now, have you ever seen the soil which is in a drought prone area? Very hard, very hard. Have you seen the soil in the moist area? Very soft. Okay. Basically how it is being bonded, how it is being held. How it is being held with, say basically what happens is the structure of a soil is nothing but the arrangement of various sizes of particles and types of particles with each other, in a place arrangement of that in conjunction with each other, whether it is organic compounds, organic components, whether it is water, air and such. So that is what is structure. This you have to understand, because if you find that the structure is such that which is contrary to your activity over there, then in such case you have to change the structure. Let me give one very simple example. Suppose you have loose soil, it is loosely bonded. I hope you will understand this. The loosely bonded soil which you have now, over which you want to make a playground, you cannot do that. The moment you find that no, the loosely bonded soil cannot be used for playground, then you have to now change the structure of it. Changing the structure means you will do some activity over there, add something, remove something, whatever. I am not discussing that here, but basically you are changing. Suppose you want an area where you require a soft soil, a little soft soil, that means you want to make a lawn, and you have the soil very hard. People who are very familiar with the lateritic soil will probably understand this. In the lateritic soil, if you find that okay, maybe the top layer is just a soil where you don't have much of the mineral rocks, but more you go down, you will find that the lateritic minerals are there, lateritic rocks are there. But suppose now you want to make a grass lawn over there, and the grass lawn should be holding the grass roots, and the grass roots should be held with a little softer soil, but the soil at that particular level is structurally so strong, so bonded that you cannot have the grass lawn. Then what would you do? You change the structure of this. How would you change the structure? Two ways. One is you remove that particular soil, remove that particular depth, and bring in better soil, which is softer soil, and replace it, and then over that you grow the grass. Or else you let the same layer be there, over which you put the soft soil, and ultimately grow the grass. So these are different ways. So basically soil structure is the different kind of formations or how it is being held together. Soil texture is basically the composition or the combination of different particle sizes of the soil. See, there is a nice nomograph I will show you. It is, if you take a clod of soil in your hand, you will find some part of the soil is very, very fine. So the fineness to the roughness, or the size in terms of fine to rough, or the grains in terms of fine to rough, this combination is basically represents the texture of a soil. It is not how it is being held. In structure, how it is being bonded, and in structure, what is the composition of it. Okay, and then once you have understood all these things, then you design the landform profile, because I am still in the broad steps. Once you have understood this, you design the landform profile. Let me just, and also after that, once you have profile you have worked out, means you have designed the surfaces and its curves, its contours, and its all these undulations. After that, you select the soil material. By which material are you going to have this, and what is its composition? Now schematically let me show you. There was original line like this, has a soil, some soil type, and which has some kind of structure and some texture, over which you want to bring in some different profile. So you change the profile to this. So this is a change profile. The moment you do the change profile, I would then advise you that have you understood what is below at this level, the soil? Have you understood this? Have you studied? Have you studied with respect to what type of it, with respect to what kind of structure it is, with respect to what is its composition, with respect to what is the kind of texture or structure? We have experienced quite often when we had been handling building designs, and for piling, we have found in some portion of the east, we have, after certain depth, we have found decayed vegetation. This decayed vegetation, let me take an example here itself. Suppose, unfortunately, your site looks very nice, the soil looks very stable, and you have to do some bit of activities over there in terms of landscape works, and you want to dig to certain depth, and after about 600 millimeter or say 1 meter, then you find it's muck, it's very, very blackish kind of muck, very soft soil. Then you have to understand that if this was a layer, and up to this layer which was very, very stable apparently, and structurally also fairly stable, and at this point the soil is very, very mucky, keep on digging. After some time again you might find that there is a rock bed over here. So what happens is, when you are trying to put a function over here, then you have to know that up to how much depth you are likely to go. Once you know how much depth you are likely to go, you just keep on digging. Study the depth by depth this soil strata. Once you are studying this, then at this point, once you reach, then you have found it is decayed vegetation. It's mucky, it's sticky. Okay, decayed vegetation. Don't stop. Go deeper and deeper, and then find out up to what depth this decayed vegetation continued. You might be very surprised to see that after about say 300, then again a good soil. So you have to understand this lower part, and this is what is the, see, generally what we say is about 600 millimeter, about, this is a very thumb rule, we say 600 millimeter to 1000, that means 1 meter. We consider this as a topsoil for our work. And for building works, the structural designer or architect is very happy if they know about the soil up to the 1.5 meter, because a standard building which will have about 1.5 meter depth of foundation, they are happy if they know about the soil of that. In landscape, certainly you are not going to go that deep either, but the thing is, at least a 600 or 1 meter you must watch, study them carefully, and don't rely simply on the superficial opinion or inference on this. So what you do is, for doing this kind of work, make a study up to 1 meter of depth, and once you have understood this in totality, and then you are now taking a very conscious decision that you are going to do something over it, because this is also going to add weight to this particular surface. It should not happen that you have decided this particular line. Of course, in nature it does not matter much, and you don't care much, because that instability which causes a little bit of local subsidence, you may not give much importance to that. But I will tell you, technically you must be very clear that whether this amount of weight of this particular volume is going to make any kind of subsidence, even a few centimeters, that you watch. That means you are studying this particular soil very carefully, and now you are designing this profile. So what I am trying to say over here is, now you are designing the profile only when you have understood all these. Okay, and then you are selecting the material. This is the profile. Fine. What material? Is it made of rocks, or is it made of sand, or is it made of mix of different granules, or is it mix of sand, other different granules of soil, rocks, shingles, pebbles, and all that. So the thing is, this has to be very clearly understood when you are working on it. So this broad step matters a lot, and if you are at least try one in one of the landscape projects where you are trying to handle this landform, and then you see that you are very clear about the soil category, the type, the structure, the texture, the composition, the chemical composition, all these things you have understood, and now you are trying to follow these 2 steps. I will be very happy, and I am sure that you will be doing a great justice to the whole work. At least to a great extent, your design is not going to be wrong. But this is not all. I will continue again to clear more of the ideas on this.